Welcome to the second half of Chapter 6, more about confidence intervals. We talked about the mean, first of all with the sigma known, that's the population standard deviation, then with the standard deviation not known, and now we're going to take a look at population proportions. And really, I've never done this before, but when I looked at it, I thought, this isn't hard at all. Why haven't I done this before? And I think if you give it a chance, you'll find that if you got 6.1 and 6.2 in pretty good shape, this is very, very similar. This will actually improve your knowledge of 6.1 and 6.2. There are a lot of parallels. With that said, let's go. Okay, this is where we end up, or where we are in Chapter 6. 3 out of 4. Yes, I'm going to do 6.4. So if you just can't stay away from it, just stay tuned. Here are 3 of the things we're going to talk about. We're going to first, this should sound familiar, a point estimate. Remember, x bar was a point estimate for the population mean, mu. Except this will be about the population proportion. And of course, all we care about really is the population, but we use a sample to get the estimate. Next, we're going to create confidence intervals for those proportions. And last of all, similar again, we're going to find out if we're going to do our research, what do we have to have for a minimum sample size when we're working with a proportion? The formula is different. You might see some similarities. Dare you to find it. All right, so what is a population proportion? Well, there are actually 2, although this slide only talks about 1. It's the probability of success, which makes sense. But success is rather general. It's whatever you're interested in. Probability of success in a binomial experiment. You might remember this. For the binomial, you had x over n. Number of successes over the total number. This is really the same. Except that instead of p, we're talking about p hat. P hat. And that means we're looking for p, but in the meantime, we're going to take a sample and get an estimate. That'll be called p hat instead of just p. And to do that, all we have to do is take the number of successes, put those in the numerator, take the sample size, put that in the denominator, and we've got p hat. And that's going to give us an idea of what the actual population proportion is. Now, we will need something extra here. Not right away, but we will need it. Q hat, if P hat is the proportion of successes, Q hat is the proportion of that we get for failures. And all we need to do is subtract from 1. Because the total of those 2, p hat and q hat, is 1. In fact, you might want to add this to your notes. P hat plus q hat equals 1, because this is a binomial, so these are the only 2 possibilities, and since the total of all the probabilities has to be 1, there you go. All right, p hat and q hat. So let's take a shot at this. We've got a survey of 540 US adults. I'd better make a list, right? So 540 is how many we're surveying. And how many said they're going to travel this summer? 378. That would be our X. They said yes. So 378 for X. And we're going to look for P hat. Now, if we had our druthers and we had the time and the money, we'd ask everyone, every adult in the entire United States. Good luck with that, right? So instead, we find a sample of 540 representative people, and we're going to take 378 over 540, change that to a decimal, and maybe depending on what we're working with, we might also prefer to write it as a percent. That's all there is to it. A small bit of calculator work. If you really, really want to do it, you could divide the 540 into the 378. I don't think you're going to do that though. So here you go. Our p hat down here, which is going to be our point estimate of the population proportion. This, with our sample, is a guess of what p is, because we don't know what it is. In this case, p hat, or our sample proportion, is 7/10 or 70%, depending on which way you like. Now, how about the confidence interval? That's what we're talking about in this chapter. So how do we get the confidence interval? Well, remember, for the mean, what we needed was the margin of error. Now, this is a little bit different, but not too. The formula is E equals ZC, that's the critical value, and we know how to find that. No surprise, we've been talking about this for a long time. We're going to use inverse normal for this if we can, and we already know how to find p hat and q hat. We just did it. N represents the sample size. Throw it in the calculator. That's all you need to do. But there is a little bit of a catch. You have to know certain things about this population. We'll get to that. So just remember, if you do this a large number of times, if you get a lot of p hats or estimates of the proportion, then the probability that this confidence interval contains has p in it, the probability is C. And we're familiar with 95% confidence, 90 sometimes, 99 sometimes. It's what you decide to make it, really. So here are the rules, not the steps. First of all, what are the sample statistics? And you've got to know the sample size, and since it's your sample, you should know the size, right? And after you've taken that sample, you'll know how many said yes or how many successes you've got. Next, you want to find the point estimate. That's going to give us an idea what that p really is. And there's how you get p hat. X divided by n as a decimal or as a percent. Now, here is a bit of the catch. You have to make sure that the sampling distribution of p hat can be approximated by the normal distribution. How do you do that? This is how you do it. It's not hard, but it's easy to forget. You have to have these two conditions with your proportion question. And you've already got these numbers, so you just multiply the sample size times p hat and make sure that that is greater than or equal to 5. Then if it is, go on to the sample size times the proportion of failures and make sure that is greater than or equal to 5. If it passes both of those tests, you're going to be able to use z values for it. Very important. So we're going to be looking for z sub c. That's what I call it, because just calling it z I think is a little bit unhelpful, let's say. And we know how to do this. As long as these conditions are true, then we can find z sub c with inverse normal, because we know that this is going to have a normal distribution. It's about normal, or pretty close. And we'll take, to get the critical value, we'll get inverse normal in the second distribution function, and we'll put the area in here. And because it's a z we're looking at, a z value, 0 and 1 go there. If we were looking for an x value, then we'd have to give the standard deviation, or the mean and the standard deviation. And for the z values, 0 is the mean, 1 is the standard deviation. And the critical value depends on what c is. We'll get to that in a moment. So that's a little bit messy, but I already wrote it. And then you want to find the margin of error. I hope you wrote this down already. Remember, put a big R there. Remember, one of the helpers you have in statistics is hitting the pause button. If you see a question and you think, and you should, let me give a try at this, see if I can do it. Because even if you don't get the right answer, you know how not to do it, and you can back up and say, oh, I should have done it this way, and you're on your way. Once you got the margin of error, it's easy. Find the right and left endpoints, and you'll have your confidence interval. For the left endpoint, subtract the margin of error from p hat. For the right endpoint, add e to p hat. And that gives you your interval. So let's actually give this a try. So this is the same example we had earlier. We sampled 540 adults. That's our N. We got 378 yeses who are traveling this summer. And those together give you p hat. And you want a confidence of 95%, alias 0.95. Let's go. So the point estimate, well, that was pretty easy. We actually already had it. You know how to get it, x over n. Once you have that, q is easy. Just subtract it from 1, and you've got q hat. N is 540. Make sure the sampling distribution can be approximated by a normal distribution. Don't jump to conclusions and try to go over that check. First of all, n times p hat, that's more than 5. Good. N times q hat, that's also greater than 5. Check. We're ready to go. Next, we need to find the critical value of the z. So inverse normal, 0.975. And maybe, I hope not, but maybe you ask, I thought we were talking about 95%. Well, remember this. Here's a curve. There's a mean in the center. Z's would have 0 in the middle. Now, confidence intervals, remember, confidence intervals, we're talking about what is in the middle. What is in the middle, area-wise? Well, that area is going to be C. And you have two places that are left. We don't know what's on the right. We don't know what's on the left. We can find that really quickly. Because remember, this normal curve is symmetric. So what's on the left will equal what's on the right. They're identical twins, except they're mirror images. So to get what this area is, take c plus 1 divided by 2. And you can use inverse normal as you have above. And you could put this into your calculator if you've got a TI-83, then you put 0.95 plus 1, that's c plus 1, divided by 2. And then since we're talking about a z value, it's automatically 0 and 1. And there is how you get your 1.96. Where's the 0.975? Check this out real fast. Take 1 plus c divided by 2. 1 plus c is 0.95. We need to divide that by 2. So 1.95 over 2, which is, guess what? 0.975. So, with that said, we've got a margin of error of 39 thousandths. So we're going to add that to p hat and subtract it from p hat. The left end point we subtract, and there's our left end point. For the right end point, we'll add it to 0.039, and there's our right end point, and that is our interval. So we can say with a confidence, 95% confident, that P is between those two numbers. And if we did this a lot of times, thousands, maybe millions of times, 95% of the time, P would be between the left end point and the right end point. Now, you know I like the TI-84. I like the TI Nspire. And I think you could actually call them your heroes. How do you do it? Well, this is a little bit different, but you might really like this. Write down these steps. First, hit the Stat key, go over to Tests. That's the one on the extreme right. You're going to pick up the A choice, which means you have to cursor down until you get to 1 prop z int. Know what that means? Well, first of all, we're talking about one proportion. There's the proportion. And we're talking about z values, and we want an interval. It's all there. You just have to get there and put in your x value, 378. Put in your sample size, 540. Put in your confidence level, 0.95, alias 95%. And hit the calculate. Sorry about hitting the space bar so loud. And this is what you'll get. First of all, it tells you what you've just worked on. It tells you what the interval is. It tells you what p hat was. In case you hadn't figured it out, it'll do it for you. And it tells you what the sample size is, which is what you put in already. There's what it looks like on the number line, 0.661 to 0.739. 95% of the time when we do this, if we do it a lot of times, that real proportion will be somewhere between those two numbers. Again, I've mentioned this before, you might want to write this down. Get some of this wording. Write it down on a piece of paper. This is for population proportions, and this wording is excellent. Steal it. Okay, let's try something else. This won't be too different. What have we got? We've got a survey of 800 US adults. Right away, we know N is 800. It says construct a 99% confidence interval. There we go. C is 0.99. We're ready for that. And we want the U.S. adults who prefer to get their news from television. Imagine that. Well, we've got not a table down here, but we've got a graphic. And what we're interested in is the bar that says television. What does it tell us? 35%. How many in that survey said, television, that's where I want my news? Well, it's 35% of the 800 you asked. Remember, of means multiply, so it's 0.35 times 800, and that is going to how many television answers you got. Remember, n is 800. So, using those numbers, so p hat you got by multiplying 0.35, no, x. You get multiplying 0.35 times 800. You already have n, and once you've got p hat, which is 0.35, you can get q hat just by subtracting from 1. There's your q hat. Now, don't go any further. Check to see whether we can use the normal distribution. So n times p hat, is it greater than 5, greater than or equal? Easily. How about n q hat? Well, that was an easy one too. 520, that's definitely over 5. So it's approximately normal since it passed those two tests. All right, so we're going to go back to this formula again. The margin of error, you can get your critical point, and you know to use inverse normal. Remember, to get this number right here, you can take c plus 1 divided by 2. Or you can you can draw a picture and figure it out for yourself. Either way is pretty easy to do. Remember, you're looking for a z-value, so mean is 0, 1 for the standard deviation. Here's your formula. All we have to do is put the numbers in. As long as you know how to use your calculator, you can take care of this with no trouble at all. And you should get 43 thousandths as your margin of error. With that, and remember you've already got p hat. P hat was 0.35, 0.35. And this, the 0.043 will be added to it, subtracted from it to form our 99% confidence interval. Left endpoint. Subtracted from p hat. There's 0.307. That's the left endpoint. The right endpoint. Add it to p hat. And there is your right endpoint. And there's your interval. This is what it looks like in the number line. And although we figure that since the 0.35 was from a sample, the actual population proportion probably is not that. But we are saying that we do think it's likely to be between 0.307 and 0.393. And again, here's that wording again. With 99% confidence, you can say the population proportion, that's what we're looking for, of the U.S. adults who prefer to get their news from television is between those two numbers, and we'll change them to a percent if we like, 30.7% and 39.3%. And why would we use percentage? Well, suppose your a television or a newspaper reporter. Using percents really connects more with the viewers or the readers. Can you do this with your calculator? Get a confidence level and a margin of error. Suppose you're starting on this and you figure, okay, how many should I have in my sample? Well, you already know how to get p hat when you have q hat. That's pretty easy. And you're going to multiply that by the critical value is z, that'll be a positive number, divided by the margin of error, which you'll decide, and you square this. So how does that work? Remember, this is just as we had before. If n doesn't end up being a whole number, round it up. Round it down, and you won't have quite enough. Now here's something that's really important. Suppose you don't have the information from previous knowledge to get p hat and q hat. If you don't know them and you have to make it up, use 0.5 for both of them. If you do have them, use them. If you don't have them, use 0.5 and 0.5 for both of those. All right, how's this work? Well, we want a 95% confidence, so we can say C equals 0.95 right away. Your estimate must be accurate within 3%, so that means that's your margin of error, and that's 0.03. Find the minimum sample size. Remember, this is the minimum sample size. Going over it is good, under, not acceptable. Notice that it doesn't give you a preliminary estimate. Oh, shucks. It would have been nice to have had that, because I already know how to do that. Wait, on the last slide we said if we don't have p hat and q hat, just use 0.5 for both. So we'll put those in. To get z critical value, inverse normal one more time. Remember, c plus 1 over 2 will give us the area that we need for z sub c. Here's our margin of error, and here's our formula. And since it says 106.7.11, 106.7 is not good enough. Bump it up to 106.8 and you'll be in good shape, or more. If you can do 2,000, that's even better. But remember, this is the minimum sample size. All right, one more question. You're running a political campaign, sounds familiar, right? And this time you do have a preliminary estimate. You have p hat. It's 31%. So what do you need also? Well, you need q hat. What's that? 1 minus p, which would be 1 minus 0.31. So q hat is 0.69. Those are ready to go. You can put it in your formula, which will look like this. And you get 913.02. So how many do you have to have at least? Well, not 913. That would almost work. Instead, you need 914 voters. By the way, take special note of, there we go. You need a larger sample size because the preliminary estimate wasn't available in the first one. All right, well, that's it, folks. I'll meet you again if you want to go on see what we can do with standard deviations and variances. It really follows all of this before. This will just make you better at working with the mean. The mean is our primary objective, but if you can do it with proportions and sample standard deviations and variances, you'll be in good shape. All right, see you soon. Bring your questions to class. Bye.